Okay, in this video, I'm going to show you how to use Newton's law of cooling, which is this equation right here. So the equation is T of t, which is just like f of x. So the temperature that depends on time t is equal to A, where A is the temperature of the surroundings, T sub O, which is the initial temperature of the object. A, again, is the temperature of the surrounding. Then E, little t is time in minutes, and K is your rate of change. So let's say that we know it takes 8 minutes to cool from 105 degrees to 95 degrees after sitting on a table in a room that's 70 degrees Fahrenheit. So this might be like a cup of coffee, okay? So it's 105 degrees, takes 8 minutes to cool down to 95. Determine the K, so we're gonna find the K value. So the new temperature is, so this T of t is like your new temperature. So 95 is equal to A, which is the surrounding temperature, that's 70, plus T sub 0 is 105 minus A, so that's minus 70, times E to the negative K times 8. And now we're just going to solve this equation. So we're going to take 95 minus 70, so that's going to be 25. And then I'm going to put this together. 105 minus 70 is 35 times E, and I'm going to write that as negative 8K. So now we're going to divide both sides by 35. So 25 divided by 35. I'm going to go ahead and write that as a fraction. If you put it in your calculator, you get 0.71, 42857, etc. Let's just leave it like this. E to the negative 8K. Okay, now we need to ln both sides. So the ln of that is equal to ln of that. So we get the ln of the decimal that's in your calculator, which comes from 25 divided by 35, is equal to negative 8K times the ln of E. Because now that this is a logarithm, we can take this and put it out in front. Then ln of E is equal to 1. So when I multiply by 1, that doesn't change anything. And then I'm going to divide both sides by negative 8. So now you might already have this decimal in your calculator, or you can put it in there now, but we're going to take the ln of that divided by negative 8. So ln of 25 divided by 35 divided by negative 8 gives me a K value of 0.042. Now it says determine the temperature after 30 minutes. So that's my T, my little t. I'm going to still use this K value, and I'm looking for my new temperature. So my temperature is still 70 plus, and then we found that 105 minus 70 to be 35. So that's going to be 35 times E to the negative 0.042, and T is 30. So remember, when you put this in your calculator, you need the beginning and the ending of your exponent. Okay, so I'm just going to do 70 plus 35 times E to the power of negative 0.042 times 30, and that gives me a T of 79.9, so approximately 80 degrees Fahrenheit.